on our cumulative frequency curve. What we're going to do is we'll talk about where it comes from, how it was made, what it means, why the shape is the way it is, etc. Just to start with, we'll figure out how we can use it. So yeah, like Jacques was saying, if we have 90, right, you can see the final point at 90, that means the total frequency is 90, which means there are 90 people or plants or animals or whatever, I don't know what it is in this case. But cumulative frequency is when you add up the frequencies. So 90 is the maximum. Okay? So what we do for the median is this going to be in white? Yeah. I'm going to go to 45, you're going to do this much better than me. Go across to the line and then go down. Right? You would not believe, ladies and gentlemen, how many people with a pencil and a ruler? Some people don't even have a pencil, but cannot, or a ruler, draw a vertical or a horizontal line, even when there's a grid on the paper. All right? If I do not draw a vertical line, what have I done? Well, I've messed up my conclusion, haven't I? My value for my median is wrong. So you have to be as careful as you can. Now, what have you got as the median then? Yes, Ed? 1.97? What's each little square worth? 0.2? Sure?
No, 0.02.
0.02. Okay, so yeah, 0.92, 9.4, yeah. So you're going for, does everyone agree, 1.97 with Aidan?
Yeah, 6, 7.
6, 7, yeah. I think we're all right. So that's my median. All right, so that's done. So what we want to do then is we can also do our lower quartile and our upper quartile to find our interquartile range. So where do you think those would be? Yeah?
1/4 and 3/4.
1/4 and 3/4. So what's halfway between 0 and 45? Yeah. 22.5. So we go to 22.5. So it's going to be slightly off, isn't it? Because we don't have enough detail in the grid to actually get those numbers off it. So that's where we start introducing maybe a bit of error into our calculations, but that's the lower quartile, and then the upper quartile will be at
77.5.
77.5.
No, 67.
So what have we got? 22.5, and then we go above 45, so 67.5. So you can end up. So I've got my upper and lower quartile values sorted. So we've got minimum there, my maximum there. So what have you just created from your cumulative frequency curve? Yeah. The 5-point summary, good. All right. So could we convert our cumulative frequency curve into a box and whisker?
Yes.
Quite often you'll see it underneath. So we've got this line here. Imagine that's the number scale. Here's the line. Here's your lower quartile. Here's your upper quartile. There's your median. There's your max. So there is your box and whisker that we did. All right. Now, what's different about that to what we were doing when we did box and whisker before? What is what we started with? What did we start with in this case?
Well, in this case, we started with a.
Well, actually, it's maybe a bit of an unfair question, because in this case, you haven't actually started with anything I've given you. But
Group data.
What have we been working with that we weren't working with previously, Jack?
Group data.
Group data. And Cameron, what does group data mean we don't have? Not accuracy. We don't have the raw data, so we don't have the detail, right? When we did box and whisker plots before, we had exact numbers, yeah? Right? We don't have those exact numbers, so actually, we can use our cumulative frequency curve, right, to estimate these things. So this is an estimate, right? An estimated value of the lower quartile, the median, and the upper quartile. Right. Let me ask you this then. Do you understand where these points have come from? Where did those points come from? Do you think? I'm saying people all the time. Aidan?
Each class in the table.
Yeah, each class. From the table, there's grouped data, and those are the cumulative frequency ones. Right? So those points come from the intervals, the classes, and their frequencies. But have we used any of those points to find our median or our quartiles? No. We've used these lines that join the points, or a curve. All right? So the curve is purely what we've decided the curve will look like between those points, yeah? So we've got another layer of why it's even more only an estimate. And if your curve is badly drawn, your results are going to be impacted, right? So if you are a scruffy curve drawer, or you use pen and have to rub it out, or you're the kind of, and we'll talk about how you draw it another time, but if you're a curve drawer like that, because you like to shade like you would do in art, you're not going to have a very good curve. What do you notice we've not done between the points? The lines are not straight. We've not joined it with a ruler. It is a curve. Is that all good at the moment? So we've got a cumulative frequency. The reason why, well, let me ask you, why are we looking at cumulative frequency curves? What are we going to use them for? Yeah?
We can probably use the curve to analyze, as another way to analyze data.
Yeah?
The shape
Any
of the
specific
curve.
type of data?
Group data.
Group data, yeah? So if you've got grouped data, you haven't got all the information, you want to find the median, the quartiles. Why do I want the interquartile range?
Outline.
Potentially I can use it to work out the outlines. But also, what's special about the interquartile range? It's the middle 50%, so we're looking at how that's spread. So we can kind of focus our efforts on that. But if we don't have the actual data, how do we know what the middle 50% is? So we've got a way of doing that. But can you see how, as we go further into this, basically what we're doing is we're finding a way to analyse things even though we have less and less and less detail, yeah? So can you see how actually when we do this statistical analysis, we really have to be careful about the judgments we make, because we can make the same judgments given hardly any detail as we could when we had lots of detail, because we have the tools to do it, right? So let's have a look. The next thing is if we want to actually create one of these cumulative frequency curves so we can use it, all right? There are other things we can find out from cumulative frequency curve, by the way, but right. Let's have a look at this question. Okay. Actually, that's not the right one, is it? Oh, hang on, let me. Okay. All right. First, what's the first step going to be if we've got this data and we want to convert that data and be able to analyze it, find the interquartile range, that kind of stuff? What do you think we need to do first? Yeah.
We need to set up our axes and plot the points of the classical.
Well, before we set up our axes, what do we actually need first? We need the, what's not in this table yet? The cumulative frequency isn't there, yeah? Let me, so we need, first of all, to create our cumulative frequency column. All right? So, what's the first value in the cumulative frequency column? 17. The next value? 4. Okay. That's not going to look very nice, by the way, but it is what it is. Okay. Rightio. So we've got our cumulative frequency. No problems with that, yeah? Well, based on that, we're going to turn this cumulative frequency data into a curve. What do you know a cumulative frequency curve will never do? So, go down. It will never go down, and you were going to say because. Yeah. Because as you go up frequency, you're adding frequency on. And what's the lowest frequency that we can have? 0, as we've got. We can't have a negative frequency. It doesn't make any sense. So what do we do now? Now we need, and this is going to look horrible, I guess, we need to just set up our grid. All right. Let's get our axes sorted. All right. Do cumulative frequency axes. All right. So let me ask you this then. How do we number our axes? How do we label our axes? What do we have on the cumulative frequency axis? What would you put? Yeah. 10 to 110. Do that. Do we need a 0? No? Okay. So there are kind of discussions about whether you have a 0 or not. All right. But we'll talk about that. So what do we want? Start as 10, go up 10, 20, 30. Well, you've got a grid, whatever you want to do. Oh, I look at that. 110. Right. What do you think we'll have on the x-axis? So we've got 0 up to 45, yeah? So should we go up in 5s? 5, 10, 15, 20, 25, 30, 35, 45. Okay, it fits. Right? Ideally, we'd have better graph paper. You know, you've got squares in your book, you make it work. I've got grid on my screen, I make it work. So here's the important bit then, the decision. So I'm going to ask you, all right? What's going to make it difficult to plot? Yeah?
The fact that the classes
Yeah.
to the same number, like 0 to 4 and 5 to 9, so 0 to 5 and 5 to 9, 10 or something. So
Well, that, yeah, that's one problem. That wasn't the problem I'm thinking about. That's the kind of practicality of how you set up your graph. I would say I can cope with the 5 to 9. I can just put a mark, and it's not going to be super accurate because you've not got the small squares, but you could do that, right? The reason why I went up in 5s is just because I didn't want to. I could have gone up in 2s or 3s, but I'd have then been huge. But you can make that decision. That's fine. Yeah, mine's going to be a little bit more difficult. But that's not actually the problem that I was thinking of. How do I, so when we had the graph, we had to plot points for each group, yeah? For each class. So how do I do that?
Well, you only start at frequency 17. So you're not starting from 5.
Again, that's not the problem I'm thinking of. That's why we can sort that out. I'm surprised you're not coming up with it straight away.
The fact that the frequency starts on a 0.
Does it though?
I mean, not the frequency,
But is that?
I guess it's not that.
I guess what I'm asking is that point we plotted before. If I go back up to here, all right, this point here is on 1.7 and a frequency of 6. What do you think the 1.7 represents? There's only one value. So what? How? Where would I plot my point for 0 to 4? Yeah?
2.
At 2. You think at 2? Is that what you're going to say?
Yes,
Why do you say it?
Because that it's the same thing as yesterday, where it's you have the least error wherever.
Makes sense. Makes sense. You take a midpoint. We don't do that because we read a cumulative frequency in a certain way. And what we actually do, a cumulative frequency, because we're adding up, how we actually read it is the point. This point here, right, on this graph, the 1.7 and, well, this point actually tells me how many people are less than 1.7. This point here is how many people are less than 1.9. So we don't say, oh, 1.9. Because what would this line mean? If these are all 1.9, what does this mean? But that would mean we've got separate people. That means, but what this point, because we do our cumulative frequency, this point here represents all the people I counted up to the height of 1.9, yeah? Alright, so therefore what we do when we do our cumulative frequency, we actually plot the top end of the group. Alright? And we say, right, so there are 17 people that are 4 or less in this case. Right? This number here, what would it read?
94
There are 94 people that are,
24 or less.
yes, not between 20 and 24, because remember, these numbers have all been added up, so I have to include it. So this says 94 people are 24 or less. Yeah? That's the cumulative effect of it. So we take the top end, we don't take the middle, although I understand completely why you said that. All right, we actually do take the top end. So when we plot this then, so my number of words is here, right? So number of words for my cumulative frequency is 17. I'm just going to put them up. So go ahead and plot your points. So 42 people at 9. 9. So they're all plotted. The next stage is to draw your curve. All right. So this is where we've got a nice sharp pencil. It's not too soft because you've brought your art pencils with you. Alright, a nice HB pencil. Should be the normal one. Alright. You're going to draw a nice smooth curve as best as possible. Just like when we were doing graphs and quadratic curves and things like that. So the idea is, obviously it's going to be easier for you. Now if that means turning your paper round or using the angle of your wrist, but we're trying to go through the points. Now, do you know what, guys? I'm quite happy with that. That's not bad, considering what I'm using. So what do we do at the beginning? Do we just leave it like that, or I know the one example I gave you before had nothing before it, but is there anything? Should we just leave it like that in this case? Jack?
Yes, because in the context. Well, I don't feel like it would extrapolate.
No? Well, if you think what each point means again, what does each point mean? The number of
Words in the sentence.
Well, under
less than, right. What's the lowest value in the table? Cameron? 0. Could I put, realistically, another point which is at 0, 0? Is there?
No, because on the table, that would mean that point is
No, it doesn't. Because this point does not refer to what's to the left of it. It just says there are 17 less than 4 words, yeah? This is 42 less than 9. It doesn't refer to what's going on before it as such. So if I were to make that point, what am I saying? That there are 0, I think it's sentences, 0 sentences with 0 or less. Is that fine to make that statement? There are, aren't there? You can't have 0 or less words in a sentence. So actually having a 0, 0 in this case is absolutely fine. All right? So I could continue this curve down to the 0, 0. All right? Now, what's not in the example I gave you before is anything less than 1.6. We don't know. The group might have been 1.6. Right? Now, the curve up here can actually be finished off, even though it's not. All right? But I would need to know what the first group was. So let's say it's 1.7, 1.8, then it's 1.92, and so on, right? Let's say the lowest group was 1.6, okay, to 1.7. Got that? Right, where would this line end up at? Liam?
I was wondering if, can we also put a point here at 0, 0?
Not 0, 0, no. Because if this was the lowest group, what's the final statement that I could make?
That you have 0 1.6.
Yeah.
Doesn't say anything.
I've got 0 that are less than 1.6 because I don't have, I'm assuming, because the table's not there, I don't have a 1.6 to 1.5 group listed. All right? So if that's 2 and this was 0, because I just wouldn't bother with that one. So what that means is this line, I would actually go to 1.6 with 0 on the frequency, cumulative frequency, and my line would actually come down like that and be finished off. All right? So it's not done in this example, I think just because it's a first example of how to do it, but this is a discussion point. So your cumulative frequency, really, your cumulative frequency axis should come down to 0. because you should have a point where there are known values less. But your x-axis, your groups, does not have to start at 0, 0. So cumulative frequency curve does not always start at 0, 0. But it should be at 0 cumulative frequency to start, at the lowest possible boundary that you've got in your table. So that means in our table, right, all of the other ones, we only look at this, but for the first group, to start the graph, we look at the lowest one as well. All right, make sense? Okay. So, quick question. Why would the shape of the curve change? So let me, well actually, are you okay with how to create one? That's all there is to it. There's nothing more. All right? It's now about interpreting it. So if I said to you, all right, here are some possible shapes. So we've got one that we've just seen like this. We could have curves that look like this. All right? We could have curves that look like that. We could have a curve that's very similar to this, but kind of just does that. All right? What would the shape tell you about the data? Is that? Yeah, so for instance, if I compare those two in the middle, all right? So this one and this one. What's the difference in the distribution there, Steph? Can you tell me? I'm going to stop you there because you're spot on, but not everyone will understand why. Why do you say that the first one has lots of values in the middle? Yeah, so as you add up, if you add a larger number, the line will get steeper. Yeah, the bigger the amount I add on every time, the steeper the line. So you can see that in the middle there, all right, this is where all the action is. And then here and here, there's not much going on. All right? But with this one, look, it's pretty consistent, yeah? It's adding on a little bit every time. So we have a different distribution. What's happening with this one? We are adding quite a bit at the beginning and at the end, and then there's not much happening in the middle. All right? So could I call this one a bimodal distribution? Why have I said that? Yeah? Yeah, so it'd be like, if I were to look at it as a bar chart, there'd be two peaks, wouldn't there? That's where they'd be. So, although they don't look like peaks, they would still represent that in the same way. All right? So we've got how to draw them and how to interpret them. So, I guess tomorrow we just have a bit of practice with what's in the book, have a bit of practice on it.